Hello, this is Juan Orlando. I'm demonstrating Lab 6, the digital clock on the FPGA. For this lab, I use the bottom right hand LEDs to count from 0 to 59. These LEDs represent the number of seconds that have passed by before the minute digit gets incremented. For the 7-segment display, I use a refresh rate of 20 milliseconds total. Which means each single 7-segment display is on for only 5 milliseconds before it's cycled on to the next. To set the time, I use the left and top buttons of the FPGA to increment each hour by 1. It's using military time, so it goes from 0 to 23:59, and then it cycles back down to 0. And the time right now is 9:51. So I'm going to set it to 9:51, and then we'll see it cycle back to 9:52 after the 60 seconds are up. So the minute counter is about to hit 60 seconds, and it's going to go to 9:52. And that's it. It's 9:52 right now, and that's the end of my presentation. Thank you. Hello. The code I used uses 3 separate modules that get instantiated in the top module. The first module that gets instantiated is the 200 hertz module, which takes a the 100 megahertz clock and divides it into a 200 hertz clock, which is used for displaying the 7-segment display. In this module, I just count from 0 to 50,000, 500,000, and then it cycles back down. Counting to 500,000 creates the 200 hertz clock, which I use in the 7-segment display to achieve a 5 millisecond clock. The second module that gets instantiated is the counter module. This module is the module that controls the 4 different 7 segments display, being the top hour hand, the second hour digit, the top minute digit, and the second minute digit. These digits count from 0 to 2, from 0 to 9, from 0 to 5, and 0 to 9. This also outputs the LED seconds. This module basically uses a single counter register, which is a 27-bit counting register, which counts all the way up to 100,000, 100 million, and then it counts right back up again. And this creates a 1 hertz clock. So basically it creates a 1-second timer, and it counts up from there. Every single time it counts for 1 second, it lights up a different LED, which is stored in another register, which is called LED. And basically it just counts up from there, continues counting up, and updates the hour second, or the hour digit, or the first hour digit, or the second hour digit, and the first minute digit, and the second minute digit, depending on where it's at in the counting process. It also takes into account the up button and the left button, which are used to to set the time on the digital clock, depending on if the button's pressed or not. And that's it for this module. For the last module that gets instantiated is the 7-segment module. This module outputs to the 7-segment display. And it uses a state machine to do it. So the state machine only cycles between 4 different states, which are the 4 different 7 segments that are being lit up at the time. And it uses a 200 hertz clock. So using this always at POSIX 200 clock ensures that the 7-segment display is only being displayed every 500 or every 5 milliseconds. And then it uses a decoder to decode the number that's coming in from the counter to display the proper number on the 7-segment display. And in the top module, all 3 of these modules get instantiated and the wires just get connected together. And that's it. That's my clock. Thank you.